Hi, I'm Emily Setu. I'm a master's student currently at the University of Alberta underneath the supervision of Dr. Jing Liu's group. If you notice, you also see the "and soon" I'll be co-supervised by Dr. Yimin Singh from NRCan. Basically, I'm going to be switching to a PhD hopefully before the end of the year. So I'm kind of in between main research projects right now. So hopefully, so it's going to be a very kind of like bare bones type of presentation, but hopefully I'll get sort of the overview and points across here. Specifically, the goal for my research now is to identify, assess, and characterize corrosion in bioenergy carbon capture and storage chains, or BECCS chains. Just a little bit of a background about bioenergy carbon capture storage. So essentially bioenergy, I think Sting kind of touched on this in her presentation, use biomass to produce energy. And from the energy from this biomass is considered sort of zero emission, as the carbon dioxide sequestered in the biomass while it's growing is assumed equivalent to the carbon dioxide released in sort of any energy production method, such as combustion or pyrolysis. However, if you add a carbon capture and storage chain to the end of the bioenergy system itself, this whole sort of system can become negative emissions, meaning that instead of adding to the overall amount of carbon dioxide in the air, you can basically start removing it while still producing energy. However, in the bioenergy production process, as well as in the carbon capture transport pipelines, there are impurities involved, such as like water, oxygen, NOx, SOx type of thing. And it's with these impurities that we need to better understand the corrosion in these areas to help make these technologies more sort of economically feasible in the future. And to do this, I basically have three main goals I want to accomplish over the entire course of my PhD. So the first would be to understand the corrosion at bioenergy production. Now, bioenergy is a very, very broad sort of field. So in order to narrow it down, we're going to look specifically at using biowastes. So not exactly like deforestation or anything, but more like the byproducts from either agriculture or municipalities itself. And then the specific production technique for the energy is going to be hydrothermal carbonization, which results in sort of a syngas and a biochar component. So definitely looking at the corrosion in this area. Hopefully, the mobility experience currently is planned to be at the NRCan facility in Hamilton, Ontario. Basically going to be doing some immersion testing there. Hopefully, that is the plan. The second goal is to understand the corrosion at the transport pipelines in the CCS chain network. This research area for corrosion in this network has been growing recent years. But specifically, I want to focus mainly on the areas of the weldments in the pipelines itself, as the welding components itself, that you get the base metal, filler metal, there is quite a big chance for sort of corrosion interactions there. So definitely wanted to understand and sort of characterize the corrosion there. And then finally is the use of machine learning techniques for corrosion severity prediction. Now, this third point was basically used to be my master's project itself. Basically, machine learning, it can, if you feed it a bunch of corrosion data that you can gather from literature, it can produce corrosion severity prediction scores based, the accuracy depends on the amount of data and the quality of data you feed it. And basically want to test how accurate machine learning prediction is in these specific conditions as well. So those are the goals itself. Very short, sweet presentation. Thank you for listening.